Hi everyone, what's up? Today I'm going to solve with you a really nice definite integral. And this is just going to be a problem walkthrough, okay? So you know how you can use substitution to solve definite integrals and how you gotta change the bounds of integration, okay? So yeah, let's do it. So today we're going to compute the following definite integral. So we're gonna have as lower bound 0 and upper bound 4. And the function we're gonna deal with is going to be square root of 3x plus of 4, okay? So this is going to be the integrand that we have. Now this is a very simple integral. Hopefully you can see that you can just use a simple substitution and you can find an antiderivative for this function, and that's exactly what we're going to do, okay? So you can see that, well, you can just let u be equal to 3x squared, not squared, sorry, 3x plus 4. So u is going to be equal to 3x plus 4. Now this is a really nice substitution because it allows us to simplify this square root. Usually you can deal with the square roots if you only have a very simple expression inside the root, but if you have some polynomial or binomial, that's kind of complicated. So this substitution allows us to just have u inside the root instead of a binomial, so that's good. Now we need to compute the differential of u to replace dx with some other value, and we're going to have that, well, the derivative of this expression, it's simply going to be 3, and we have 3 times dx, okay? Which means that du divided by 3 is equal to dx, okay? Now I'm going to rewrite this definite integral like this. So we know we can move this 1 over 3 to the front, and we're going to have 1 over 3 times the entire integral. And this is going to be 1 over 3 times, this is going to be square root of u, because remember u equals 3x plus 4, so you can just simply, instead of writing 3x plus 4, well, you can write u. And now what about dx? Well, we know dx is going to be equal to du divided by 3, but that division by 3 is already accounted for when we moved this coefficient outside, so this is just going to be du, okay? And now what about the bounds of integration? Well, let's do that. So the lower bound, remember, you're just simply going to grab the lower bound and evaluate it at u, in the function u, and then do the same thing for the upper bound. So we know that the lower bound, which I'm just going to write as LB, is going to be u evaluated at 0. Now u evaluated at 0, well, that's just going to be 4. And the upper bound, which I'm going to write as UB, is going to be equal to u evaluated at 4, okay? And we know this is going to be equal to 3 times 4, that's 12, plus 4, that's 16, okay? So we have 16 here, okay, nice. So now we can plug these values into the definite integral. We're going to have 4 as the lower bound, and this is going to be u, of course. So we have u equals 16 up here. Nice. And this is very simple to solve. This is just going to be a coefficient, so you can just add 1 to that coefficient, and we're going to get the following. This is going to be 1 over 3 times, now let's see what we get. So this is 1 over 2 plus 1, that's going to be 3 over 2, and you also need to divide by that number. So dividing by 3 over 2 is the same as multiplying by 2 over 3, and this is going to be u to the 3 over 2, okay, which is the exponent that we get. And we want to evaluate this entire expression at u equals 4 and u equals 16, okay? Now remember, we don't go back to the original function. You don't need to substitute u for some x value, for some expression in terms of x, because the bounds that we have are already in terms of u. So you can just simply, compute the definite integral with respect to u, and that will be the answer for the definite integral with respect to x. Okay, and it's going to be like this. And now let's see what we get. So over here, we're gonna get the following. So yeah, I'm just gonna keep 1 over 3 outside, and I'm gonna write it like this. So we're gonna have 1 over 3 times, now we know 2 over 3, actually, yeah. Now actually I'm going to combine 2 over 3 and 1 over 3, I think that's way better. So this is going to be 2 divided by 9 times, so we're gonna have 16 to the 3 over 2 power, this exponent, minus, we're going to have over here minus 4 to the 3 over 2, and it's going to be this, okay? Now how can we simplify this? Well, remember, these exponents are just going to be 3 times 1 over 2, which means that this is also the square root of 16 and the square root of 4, and then that's to the 3rd power. So we can do something nice. So here, this is going to be 2 divided by 9 times Now 16, square root of 16, we know that's going to be 4. So we have 4 to the third power minus square root of 4, that's going to be 2. And we have 2 to the third power, so it's going to be 2 to the third power. Okay, and we know that's going to be 16 times 4, that's going to be 64, okay? Because you have 32 times 2, that's 64. So it's going to be 2 times 9, 64 minus, that's going to be 8, okay? And now this is very simple to solve. This is going to be 2 over 9, and now we just need to complete this subtraction. And this is just going to be 56, okay? So we have, how should I write it? 56 times 2, that's going to be 112. So I'm just going to write 112 divided by 9, okay? So 112 divided by 9, yeah. You know, everything from here on is just simplification, you know? It's just, you know, the algebra and the arithmetic, which, you know, it's kind of annoying when you're doing calculus and you have to do, you know, a lot of arithmetic, but that's how it goes. So yeah, yeah, this has been the entire video. This has been the solution to the problem. I hope that you enjoyed this video, you learned something, and see you in the following one. Bye.